So let's begin. Good morning, everyone. So this is Francis Palma, and I will be delivering this lecture on requirements engineering from Kalmar. I guess everyone can follow me in Växjö and online. So this course has 3 parts, as you already know. And the first part, and I also believe everyone submitted their assignment 0, right? Because I think there was 60 students, but we received around 42, 43 assignments. So not all of you submitted. So this lecture on requirements engineering will be on 4 sections or 4 segments. And the first 2 will be more theoretical, and the second 2 will be a little bit about modeling and how we can use different tools for requirements engineering. And as a reference, in this lecture I used 3 books, so you can choose any of them. I mostly followed the first book on requirements engineering by Jan Somerville, and that is about more practical things basically. And of course, requirements engineering is more practical problem. And you can also follow the second book, which focus more on UML and designing, and it will give you some more software design ideas. But of course, the third book is more classical book, more well-known book on software engineering by Somerville. So during the lecture, you can stop me anytime, and you will find the lectures are self-contained. I mean, what I mean by self-contained is that they have many information, and you barely need to look at those books basically. So you can follow the lectures and the slides, and your assignments will be based on the slides basically.
And
yeah.
Johan says you have to press mixed.
Okay. So I think everyone can see the slides. Sorry. So the assignments will be based on the slides, so you barely need to look at the books, and that's why the slides has many information. So as you already know, we have 3 main segments, and the first segment is the requirements engineering that I will be responsible for, where we will be looking at the understanding of software requirements and requirements engineering, and in particular how we elicit software requirements. Then we also have software validation and management, where we try to analyze requirements and how we can check that requirements are correct and valid, and how we can manage the changes in the requirements, because requirements are changing constantly. And in the last 2 segments, I will look at the UML modeling. I already quite sure that all of you know about UML, and I will touch a bit about UML, and so that you can use this UML while you are doing your project, the software engineering project at the end, and also the first assignment 1. And I also will introduce a tool. This tool is very new, and this tool was developed in University of Trento in Italy. And you can use this tool for requirements modeling, in particular security requirements. So the first topic today. So in this first topic, we will have 5 main segments again. So these are the subsections. So in the first section, we will introduce the requirements and what is requirements engineering basically. Then also the requirements document, that is the most important output of this requirements engineering process. And what we mean by requirements elicitation. So we are gathering requirements from stakeholders. So what do we mean by requirements elicitation, and what is the best way to elicit them? Then we also have requirements analysis and negotiation. So requirements that we elicit might not be always perfect, might not be always good. So we need to analyze them, and we also need to negotiate those requirements with stakeholders so that we can come to a conclusion or a set of agreed requirements. And finally, I will show some good practices, I would say best practices to describe requirements. So requirements is not just a language or natural language or modeling. there is some good practices that makes the requirements good and well defined. So let's go to the first one. So what are the requirements? So requirements are simply description of what the system should do. In other words, how the system would behave. So the system behaves basically through its functionalities. And it can also define the system property or attributes. So those functionalities, they can be done in an insecure way or inefficient way. They can be also done in more secure and efficient way. So this property and attribute defines those criteria, how those functionalities will be implemented. Then we also have a requirements definition stage. So requirements are basically defined early stages. So if you remember the waterfall model, requirements engineering or definition of requirements are always done in the first stage, right? So it's never done during the development or during the maintenance. So what requirements describes? Requirements describes, as I mentioned before, many things. One of them is the functionality. So that is the user level facility. So user may want, I want a spelling check or a grammar check in the word processor, for example, in Microsoft Word. So this is a very particular, very specific requirements from a user. And there can be a very high level system attribute, like I don't want any data visible without proper authentication. See, this is like a security requirement. So this applies to every segment or every window of a software. So it's very general to the system. It's not a particular feature or functionality. Then we also have a specific constraint on the system. So let's say we have a device that reads sensors, and we want that sensors to be read every second, but 10 times or maybe 100 times. So this is very specific constraint on the system. And then there can be also a development constraint or technological constraint. So the system can be or should be or have to be developed using only Java or other languages like Ada. So these are different kind of requirements from the different stakeholders or different people who are engaged in the software developments and with the software. So overall, the requirements should always focus on what should be implemented or what should be developed rather than how. So these what keywords basically describes the requirements. So what are the systems, what are the functionalities systems have? So there is various definitions of software requirements. So one of the most acknowledged and widely accepted definitions is by IEEE. So I assume you already know what is IEEE, right? So they have a dictionary that is called IEEE Standard Dictionary of Software Engineering Terminology. It's a large dictionary that defines all the software engineering terms. So do you know about this dictionary? So it defines all the software engineering and computer science and other IT terms that are defined in a standard way, and this is one of the most standardized definitions of software engineering concepts. So it defines requirements as a condition or capability, and those are basically known as objectives to the system. So those objectives are the condition or capability needed or required by the system by the user. Then requirements are also conditions or capability that a system should have, but this system also have to satisfy the contract or the standard. So the contract, what we call contract, is the requirements set document or sets of requirements. That is the contract between the user or the end user and the developer. So the company who is developing the system and the end users who are using the systems, they have a contract, and we call this contract a requirements document, for example. And also we have standards and various specifications. So while we are developing requirements or developing the system, we not only have to meet customers' requirements, we have to also meet the standards or various specifications like IEEE standards or ISA standards. And of course, those requirements are or capabilities should be documented. So if you have requirements in mind and you just write the code, that will not be formally a requirement. You have to document it, and document it in a way that people from all background understand it. So that's the purpose of this documentation. So far we discussed what is requirements, but what is requirements engineering? So we have requirements, we have requirement engineering, and we have another term that I will come later, that is requirements engineering process. So requirements, as I mentioned, are descriptions of what we want. Then requirements engineering are basically different activities. So those activities can be structured or not, but those are simply a set of activities that involves discovering or documenting or maintaining a set of requirements. But the important thing is that this requirements engineering should be deal with the computer-based system. So if it's a requirement for a machinery system, it will not be called requirements engineering. And this requirements engineering term is particularly applicable for software engineering or software development. So that's why they have a emphasis on the computer-based system term. And the engineering term is very general or common, because there is many engineering, like there is mechanical engineering, there is civil engineering, there is chemical engineering. So why it's applicable to software? Because in software engineering or in requirements engineering, we have to do it, or we can do it systematic way and repeatable way. So every time we do the same or develop the same software, it will do the same thing, no matter how you do it or what technology or what language you use it. So that's why it's related to engineering. So there is this very strong definition, I would say standard definition by Boscher and Steve in their book back in 2000. So it's fairly 18 years old definition. This is one of the first definitions of requirements engineering. So it defines requirements engineering as the process of defining, documenting, and maintaining requirements in software engineering design. So you have to define the requirements, you have to document it, and it should be well documented, and you have to maintain it once it's defined and documented. But it doesn't say the order or the process or structured process of these activities. That's why the software engineering process comes. So as I mentioned before, software requirements engineering are done basically in the early stages of waterfall model, but in the recent software engineering methods or methodologies, there is practices like requirements are continuous evolving. For example, the rational software, the rational unified process, RUP, where you start with a requirement in your mind, you write it down, you develop it, you test if the requirements is working well, and you keep continue with other requirements in the same way, maybe parallelly, but at the same time those requirements might evolve. So it's a continuous process rather than in contrast to the waterfall model, where you define all the requirements at the first, then you go for the development of all the requirements, then you go for the testing of all the requirements, and so on. And it's more common, more common in these days, because in agile or extreme programming, these requirements also evolve and runs parallelly with other activities. So as I mentioned before, there should be a outcome, and the outcome of a requirements engineering process or requirements engineering is the ultimate outcome is basically requirements document. So we want to produce a final document that is official, of course, that gives you everything about your requirements. So it will involve, or it will include, not only the descriptions, but also how you look at them from the developer's perspective, and how you look at them from the user's perspective, and how you plan to implement them, and also how they are related to each other. So it gives basically all the details of requirements, but in a more formal way. It's not informal document. And usually these requirement documents are known as different names, but based on the company or based on the people, they call it functional specification, but it's not necessarily always functional. It also includes non-functional specification. Then it's also called as requirements definition. So as I mentioned earlier, it's not only definition, it also gives other description, other details of the requirements. And the most common term that people use these days is software requirements specification, so SRS. But it can be also called safety or reliability plan, but this is more about non-functional term. So we looked at requirements. What are requirements? What are requirements engineering? What is a requirements document? But we did not look yet at the types of requirements. So there are different types of requirement. Broadly, they can be classified in two different ways. So one is based on the level of details, how detailed they are described. So the first one is the stakeholder requirements or the user requirements that we basically collect from different stakeholders. It's not only end users. It can be manager. It can be people who will be using the software, people who will be benefited from the software. Let's say the banking software. The people who work in the bank, they are using the software, but as a client of the bank or as a customer of the bank, we are benefited from the banking software. So we are all stakeholder. And usually requirements or the user requirements are written in the high-level language, so the natural language. You can use informal diagrams, but diagrams are not usually used for writing the user requirements. And then there is also system requirements. So as I mentioned before, in the requirements document, you don't have not only requirements in the natural language or in text. You might also have models and designs, and maybe more about technologies that you are going to use. So system requirements basically give a more detailed view of each user requirements, and it can include graphical notations. It can use mathematical models or other specifications. It can also include technological dependencies. So what type of system it needs to be run, what types of user skills we need to run these requirements or to use these requirements. So based on the level of details, the requirements are two kinds. So one is user requirements and other one is system requirements. And then also based on the goals of the requirements, we have two different requirements. So one is functional requirements. Basically, by goals, I mean what objectives we want to achieve. So either we want to achieve a functional objective, like I want to, so for example, the spelling or grammar check, as I mentioned as an example earlier, and this is a functional objective, and also a non-functional requirement. So those are non-functional objective, and those are basically about on those functional requirements. So I want a functional requirement, but I want that functional requirement in some way. So maybe in a more secured way, or maybe in a more efficient way. So I have two examples from here. So the functional requirements example can be a system must provide some facility for authenticating the identity of a person or a user, but this authentication should be done in 10 seconds or less. So this 10 seconds or less is kind of non-functional requirements on the authentication process. And what I can suggest from here is that, as based on the examples, usually non-functional requirements can be decomposed into functional requirements. I will give you an example here in the next slide. So let's say the same example that I gave before. So the authentication process should be completed in 10 seconds or less. This is a non-functional requirement. If I decompose it we have three different goals, let's say. The authentication process, it should be completed. So by completed here, it means it should be successful, and it should be done in 10 seconds or less. So this authentication process is a functional requirement, and the rest two, the completed and the 10 seconds, are constrained. So if we impose those two constraints on the functional requirements, it becomes a non-functional requirements basically. So the non-functional requirements are defined as a combination of functional requirements and constraints. So so far we talked about requirements engineering process, and types of requirements. But we also mentioned that requirements should always come from stakeholders. But what are those stakeholders? So stakeholders are basically anyone who is directly or indirectly affected by the requirements, or who has influence on the system requirements. So who will be related to the system to be developed in anyhow or any way. And the examples of those stakeholders can be end users. So for example, again, for the banking system, the workers in the bank, then the managers, so the boss of those workers, the engineers responsible for the development, so the software developers or requirements engineers, and the customers of the organization. So if it's a ATM, for example, I am directly using the ATM as a customer. So also my feedback is important as a stakeholders while a company is developing a software for ATM machine, for example. And then there is also external bodies. So while we are developing a financial system, for example, we need to make sure that we are following financial rules and regulations. So those regulators are also part of this system as a stakeholders. So here is an example. Maybe I can ask you. So if I want to develop a automated railway signaling systems, who will be the stakeholders? So based on the examples above, any ideas? Yeah, that's for sure, because they are buying tickets, they are traveling, they are getting on board. Any ideas? Any more ideas? Yeah, well, engineers who are developing the system, or engineers who are operating the trains. Yeah, so there might be, of course, others, but as we mentioned, the operators. So operators could be those engineers that are running the train crew that are on the train, help people and checking tickets and other stuff. Then the railway managers, the passengers, of course, the installation engineers, because they are also dealing with the signaling, and also the safety certificate authorities. So as a regulatory board, they are also part of this system, because they have some specific safety requirements for the signaling system. So as a good practice, while we are drawing the requirements, so while we are collecting the requirements or writing the requirements in the beginning, we should make a list of stakeholders. Basically, while we are writing a requirements, we should also write the source of the requirements. So who is proposing these requirements, or who is suggesting these requirements, and why? So if you collect this data in the beginning, it will be easier also for the developers to get the stakeholders' perspective of the requirements. So always make an explicit list of stakeholders while you are collecting the requirements by noting down the name of the person or the role of the person who is suggesting the requirements. So what is the requirements engineering process? So as I mentioned before, there is a slight difference between requirements engineering and requirements engineering process. So the requirements engineering is a set of activities. So it involves collecting, defining, or maintaining system requirements. But when you call it a process is always a systematic, structured set of activities, right? So it has always a blocks of activities. So it when you call it software requirements engineering process, it should be structured, and it should be followed based on the structure. So we cannot skip a step until you move to the next step, basically. And the main outcome of this requirements engineering process is always the requirements document. So in the requirements engineering, your outcome can be a requirement specification, but in your requirements engineering process, your outcome is requirements document, and there is a difference between requirements specification and requirements document. I will also mention it later. And a complete requirement engineering process should have this thing specifically mentioned. So what are these things? So what are the activities will be carried out as a part of this requirements engineering process? What are the structure or schedule of these activities? So when these activities will be done? So basically it's the order of the activities. And then who is responsible for each activity? And for each activity, like requirements elicitation or requirements validation or even requirements maintenance, those are roles for or responsibilities of different people. So we have to define those responsibility. And also the input and output from each activity. So whenever you are defining a process always have input and output, so you have to define those. And also what are the tools you will be using for those software engineering activities within the process. And these days there are many tools available to support your software engineering process. So in reality, basically very few organizations focus or follow this kind of structured software engineering process. They mostly rely on or focus on requirements document, basically, because that's the most important thing and that's the ultimate output of this process. And as things are getting more agile and more extreme, people really don't have much time to follow all those structured process. That's why they come directly, or they land directly on the requirements document. So I want to give you a spiral view of the requirement engineering process. So as you can see, the process has three different activities, or main activities, I would say. So requirements elicitation, where it all started, requirements specification, and requirements validation. And the ultimate goal or the output of this requirements engineering process is requirements document. But how it works? So it starts with the requirements elicitation. So as you can see, we have three different levels of requirement specification. You also have three different levels of validation. So it starts with the requirements elicitation, then it goes to business requirement specification. So business requirements specification, they are very high level requirements because they can be broken down further, and that's how you get the user requirements. And then when you go up, you go systems requirements specification. So this is very high level and very low detailed. Then you go more up, you go more low level and more highly detailed requirements. So you describe requirements in more detailed. So once you have business requirements, you check the feasibility. So if those are basically visions. So what we want in the software as a high level vision. And once you study the feasibility, you go to the user requirements elicitation. So you come here. And from the user requirements elicitation, you basically go for the specification. So these are just the gathering of the requirements, but these are the specifications of the requirements. And once you have the user requirements specification, you come to the prototyping. So you make a demo or demo software of your final product using some technologies or some languages. And once you've done the prototyping, you go, so you have the system, a demo system. So you go now system level elicitation, from where you go basically system requirements specification. So those are the highest, at the lowest level of representation, but with most detailed. And once you have the system level specification, you go for the reviews. So you review with your team. So those system level specifications have models, they have descriptions, they have diagrams, they have mathematical notations, everything. And once you have them, you review with your team, and this team combines all the people with all the skills and backgrounds from different stakeholders. And once you agreed with your review, you basically generate the requirements document. So it's kind of a spiral process where the more you travel, the more mature you get in terms of software product and in terms of the requirements document. But of course, the requirements engineering process might have problems. So these problems might create either your poor product, or these problems might these problems might be created because of the loophole in your process. So you can find these problems from two different perspectives. One is the process and one is the product. I will show you some questions later on, and if you answer yes to any of the questions below, you might say that your process or product has a problem because of the requirements, or the requirements were not well defined. So the first question is your requirements engineering process usually over budget, or does it take longer than predicted? If yes, that means you have a problem in your process. Then the second question is, do people involved in requirements engineering complain that they do not enough time for or resources to do their job properly? If yes, again, that means you have the problem in the process. Then are there complaints about the understandability of the completeness of the requirements document? If you answer again yes, that means you also have the problem with the process. Then do system designers complain of rework resulting from requirements error? If there is if you have to do some work repeatedly because of the errors, that means again you have the problem of the process. And then do customers of your system fail to use all the system capabilities? So you have a delivered product, you have a number of features in there, but customers are not able to use all the features. So if there is this is the case, so that means there is a problem in the product in the first place, and this problem of course happened because of the problem in the process. So the requirements were not well analyzed. And finally, then if there is a high volume of change requests immediately after the system is delivered, then there might be also the problem in the process. So that maybe the requirements were not well defined, and they were not well developed accordingly, and customers are requesting a high number of changes on those requirements. So the requirements was not well analyzed basically. So these problems are mixed of process related and product related problems. So if you find any of the problems here, that means your requirements engineering process need to be refined and revised. And the last one is, does it take a long time to agree on the system changes? So there was a change request, but this change needs to be reviewed, and if it takes very long time to agree on the changes, that means you also have a problem in the process. But the question is, what if you answer no to all of those questions? So you have an idea? Because we said if yes to any of the questions, that means you have the problem either in the process or in the product. But what if you answer no to all of the questions? It's very simple, because if you say no all of this, that means your requirements and your products are perfect. So you don't need to basically have any requirement engineering approach even. But in reality it's not. So that's the reason why there is requirements engineering and requirements engineering process. But what is a good requirements engineering process? In simple word, there is no one good requirements engineering process, but it also depends on the organization and how they adopt and adapt to the problems and the system they are developing and the changing technologies. And also, one good requirements engineering process for a particular organization does not fit to another organization. So this varies across organization. But most of the standards that are developed for requirements engineering are also does not deal with greatly with requirements engineering process. So there are some standards I will show you later, where it says that it want to improve the requirements engineering process, but it basically does not. All it does is deals with the output of the process, so the requirements document and the structure of those documents. For example, here I have US Department of Defense Standard 2167A. It has the goal of improving requirements engineering in their team, but it's nothing like a process. It's all about requirements document and representing requirements in a good way. But regardless of the standard and regardless of the best requirements engineering practice, a requirements engineering process will be, or I would say a good requirements engineering process will always have these 3 steps, no matter what company you are working on, no matter what systems you are developing. So the first step is requirements elicitation. This is basically the discovery of requirements by discussing with your stakeholders, and then the requirements analysis and negotiation. So once you elicit or gather the requirements, you basically analyze them to see if they are complete, if they are conflicting, and you negotiate with the stakeholders if you do not agree as a developer or as a stakeholder. And also the requirements validation. So once you make the specification of your requirements, you have to validate it. So you can validate it by checking or maybe even by reading the requirements document itself. So you have to do a careful check of the requirements, so in terms of consistency and completeness, and also if it conflicts with other requirements. So for the requirements engineering process, there is a standard. So you already know, I'm sure, ISO, right? So they have hundreds of thousands of standards for different industry. So one of the standard they had ISO 9001, and where they proposed a guideline for the organizations that want to develop software, not only software, any product, and they want to make sure that those organizations meet the customers and stakeholders' requirements at the same time, and they comply to the regulators or standards or any other constraints. For this, they've defined 7 quality management principles, or 7 good practices, basically, that if you follow them, you will end up with a good quality system. But this is not for software in particular. It can be applicable to any product. So one of the 7 quality management principles is customer focus, and this is also very applicable to softwares, because softwares are also very highly customer oriented. So the end users or customers usually express their requirements. So you have to make sure that you gather all the requirements from them, and you are giving them the highest importance. And sometimes you have to even try to exceed their expectations, so that you make sure that your activities are all customer focused. Then the leadership. So leadership in software engineering, not only, but also all the industries, it matters. So a strong leadership help organizations and software companies success. So it's important to have a good leadership that you can rely on, and that they can guide you in an effective way. Then the engagement of people. So people from all level, from all skills and all background should be engaged in the software development. So it's not only in software development, but also applicable to other industries, as I mentioned. But also it's important, now people, like if I develop a banking system, the managers, the workers there, the customers, the financial regulatory bodies like central bank, so they should be all engaged in the process. Then the process approach. So as I mentioned earlier, so requirements engineering is not only activities, it's a structured set of activities. That's why it's a process. So it's a requirements engineering process, and everything you do should be a well-defined process. So you should not do stuff during the development randomly. And the organization you are working for, they should have a defined process for all kind of activities, and that's what it's called, process approach. And it of course it increases your efficiency and your accuracy. Then the improvement. So improvement is also important for software development organizations, not only, but also other organizations, but it applies to software development organizations in a way that technologies are changing constantly, so you need to adapt yourself to new technologies. You need to improve your skills, and this is particularly important for IT companies, because if you don't improve yourself or improve your skills, you will be lagging behind than other competitors. So improvement is always important, and is part of a quality management principle. And then the evidence-based decision making. So you can take decisions based on your experience in the software development, but it does not always work well, because every product are different, every people are different that you are working on. So the managers should decide based on data or information that what we have. So if we decide based on our experience, it might not well suit the problem we have right now. So for the problem we have right now should be handled using the data or information that we have right now. So based on the evidence, basically. And also the relationship management. So if you have improvement, if you have engagement of people, if you have process approach, if you have all the quality concerns defined by ISO, but you don't have good relationships with the vendors, for example, or other external stakeholders like contractors or service providers that you are relying on to get their service to develop a system, it will also not help to improve the quality of your product, because you also need to maintain a good relationships with your external stakeholders. So in broadly, there is two main software engineering process standard. So one of is ISO IEEE 9003 2018. That is the latest standard, and it is particularly focused on software engineering. And this standard or guideline basically rely on ISO 9001 that I mentioned earlier. So using those 7 quality management principles, it define a well-defined process for requirements acquisition, for supply, development, operation, and maintenance. And if it's not free, that's why I don't have all the details on this, but I will check if I can get these guidelines. But this is the latest and one of the most accepted guidelines for or standard for software engineering process, requirement engineering process. Then you also have Department of Defense standard by USA. So as I mentioned before, their goal was to improve or propose a requirement engineering process, but at the end they came up with a uniform way of expressing requirements. So basically that deals with the requirements document rather than a requirements engineering process. So this was all about requirements and requirements engineering. And now we will go to more detailed about requirements document and other subsections we mentioned. So the first thing is the requirements document. I already mentioned some of it. So the requirements document is basically the official statement of the system requirements for customers, end users, and software developers. It also works as a contract between the software developers and the end users. So depending on the organization, as I mentioned, that it's known as a different name. So one of the most common name is SRS, Software Requirements Specification, and you can also call it functional specification or non-functional specification. But the good quality requirements have some good attributes. So a quality requirements document should be always clear and consistent in its expressing requirements. It should be really understandable. So if someone reads the requirements documents and does not understand, that means your requirements is not well written. It should be as concise as possible, and any kind of changes should be easy to make. That's another important thing. So who are the target audience of the requirements documents? The target audience of the requirement documents are same as those who are stakeholders. So primarily the system customers. They are the one who is proposing or specifying requirements, and they also have this requirements document when basically you are delivering the product, and this requirements document they got basically are the user manual, and user manuals always have those kind of function descriptions of functionalities that they ask for initially as a requirement. So this requirement document are important for both pre-stage and the post-development stage for the system customers. And then there is also managers. So he's responsible for the overall planning and budgeting, and also the scheduling. So requirements documents also an important source for planning and also budgeting. Then you have system engineers who are concretely developing the systems, and they use this requirement document as the basis of their implementation. So in terms of design and development and test. And then you also have system test engineers who gets the requirement that they are testing and verify whatever requirements in the requirement document are, if they are well implemented or if they are correctly implemented or not. And finally, the system maintenance staff. So when there is changes in the requirements or even in the system, they want to make sure that they make the changes in the requirements document in the first place and then in the system, and also vice versa. If something changes in the system, they want to make sure that it was also reflected in the requirements document. So overall, requirements document is not a design document, so it's also very important, and it should focus on what the system should do without how it should be done. So how it should be done is basically up to the software engineers or system engineers who are developing or test the system. So there is no standard or specific requirements document structure. It depends on the custom or practice of the organization. So many organizations has their own requirements documents, but there are benefits of this having a standard format, but I will show some of the document structure later. So one of the key benefit is easy to find information from the requirements document, and the relationships between different sections, different requirements, different subsections. So that's the purpose. One of the purposes basically to have a standard format. Then for the writers, if you are writing a requirements document and you have a template, it will be easier for writers to follow the template and write all the mandatory fields, for example, and in this way they will not miss any crucial information for about any requirements to note it down. And also for the reviewers, if you have a standard template or a standard structure, the reviewers for reviewers it is easy to review them, and they cannot miss any of the important part to review. So one of the widely accepted structure or standard for requirement document is IEEE ANSI 8301993 standard, and it's also widely accepted in the or widely used in the industry these days. So it has 5 different segments. So in the beginning, as you can see, there is the introduction. So this introduction is basically the metadata of the document. It's nothing about the requirements or nothing about the system. So it describes the purpose of the requirements document. So it describes the purpose of this document, the scope of this document in section 1.2. Scope of this product. So in which context this product is being developed. It also defined different definitions and acronyms and abbreviations, and if had some references. But the section 2, that is general description, that is more about products. So it gives you a high-level overview of the product, including the what are the functions that this product will be delivering. Like in 2.2, it's describing the business requirements, let's say, and also user characteristics. So what types of user will be reading this document and using this system, and other general constraints and assumptions. But the most important part of this structure or this standard is section 3, where you mention in detail all the functional and non-functional requirements. But in section 4 and 5, you basically put your appendices and indexes. That is optional and may be helpful for the readers. So this standard that I mentioned is from IEEE. So these are always not followed by the academia or researchers. But there is another format or another standard that was delivered or proposed by the academics people. I don't know if you can see it, but I can go through each of the rows here. So the first, it has some similarities with the previous standard. So the first part is the preface, where it should describe about the metadata of this document, basically the version, then who will be the reader of this document, and the summary of changes, for example. Then you also have the introduction section, where you describe about the system. So it's basically section 2 here, the general description. And then you have glossary. So here you put different terms, definitions, and abbreviations. Then you have user requirements definition, and here you put all the functional and non-functional requirements. Then you have the system architecture that presents a high-level overview of the design. So how the system will look like once they will be designed and delivered or developed. Then you also have the system requirements specification. So this system requirements specification is basically the combination of user requirements and those non-functional requirements, and also any other external interfaces they will be using. So it's more detailed than the user requirements definition. Then system models. So here you can put your let's say UML models or data flow models or object models. So all the diagrams and models will be in this section. And then the system evolution. So it defines the changes. So what are the changes from the previous, and what could be the changes for the next version? So potential changes basically. And what will be the actions for the previous changes and what could be the actions for the potential changes. And finally, appendix and the index, that is same as the previous standard. So regardless of the organization and regardless of the structure, I showed you two structures of the document. These information are important and should be always in your requirements document. So the first thing is the overview of the system. So basically what the system is about and what it does, and what will be the benefit of the system and who will be the beneficiary of the system. And the glossary explaining the technical terms, so it's also similar to the previous structure. The definition of the services or functional requirements, so it has a separate section for functional requirements. This is because this is the most concrete and most important to the end users. A definition of the system properties or non-functional, so they have a separate section for non-functional requirements apart from functional requirements in section 3. And the constraint on the operation of the system or system development process. So any kind of development constraint basically that or any kind of technologies you might need for developing certain requirements you mentioned here. Then you also have constraint on the operating systems environment. So you describe basically the host computer or the system where this software will be deployed, and what will be the changes maybe in next 5 years or 2 years. So the system performance might improve, or the processor speed or even memory might need to be changed. So what will be the changes in the environment? And finally, you should put some models in your section 7. So as unlike the previous structures where they provide the models in the middle of the document, here they suggest to put the models at the end of the document as a supplementary material. So you have the document and you have the structure of the document, but in the previous two structure, in the introduction section, I did not show, or they did not show to use a separate section or maybe subsection called how to use the document. So it's always good to have this subsection in the introduction section to have like how to use this document, because if a document is long and very technical, it will be hard to read and also to understand. So it's good to have this subsection on how to use the document. So the benefits will be, of course, the reader will spend less time on understanding the document. And if you mention any technological knowledge that a reader should have in this section, for example, then the readers can know beforehand, before reading the whole document, if they have problems in that understanding, if it's due to their understanding problem or lack of technologies, or is because of the document is not well written. So there is two benefits. So users or readers cannot blame the writer that you did not write the requirements document very well if you mention what are the technologies or what are the skills you need. So this how to use this section may include these 5 different modules. So of course the first thing is the target audience, so that wrong people doesn't read this document. Then also the technical background. So even the right people are reading this document. If I don't have certain competencies or certain skills, I might not be benefited from this requirements document. So you should also mention what technical background you need to read this document. And of course, you might have a summary where you point out to different overview sections. So basically, before going to further details of the document, of the requirements, people can read these overview sections and get a overview or the big idea of the requirements, what's they're about. And also sections of the documents, if there are sections for any particular readers or that are not for general people, you can mention those sections in the how to use document section, subsection. And also the order dependencies. So some certain sections might be dependent on other sections. So this also should be mentioned in this subsection. But this is also a important part of the requirements document, but it was not provided in the previous two structures. And also in addition to the how to use document subsection, so you should also have a subsection called summary of the requirements, and it always good overview of the requirements for the reviewers, and it has other benefits. So one of the benefit is you can by just reading the summary, you can identify the critical requirements, and if you find any critical requirements, it's always easy to prioritize them and to take care extra for those requirements. And also if you provide a summary of the requirements, it will be easy for readers to understand the requirements from the high level point of view. So they don't have to understand the requirements by reading the detail of the requirements. And it will be work as a map of the requirements in the document. So if you have a summary of the requirements, let's say in the introduction section, and if you have 5 requirements in the document, that means you have 5 details chapter. But if you have a summary that have very few lines of those requirements and refer them in the consecutive chapters, it will work as a map between those requirements and the chapters basically. So the summary of the requirements can be written in many different ways. So one of the simplest ways is to have a numbered list of the requirements, but this might not be always helpful because it does not show more information than any text. It can be also based on the classification structure. So you might have a table that is more efficient to show the similarities and dissimilarities between requirements. So the table is always better than a numbered list. Better than table would be a graphical view of the requirements. So you put a requirement in the first node, that is the main requirement maybe, or the main business goal, and then you put other requirements as a sub node or as a tree structure. So it will show the relationships between requirements. So it will be easy to get which requirements are related to what requirements. And also always try to organize the requirements as a part chapter basis, so the readers will clearly see what requirements are presented in each chapter, and it's in this way it's easy to change also the document. So if you need to modify or remove one requirement, you just remove or modify one chapter. So there is some best practices for writing requirement document, and these best practices are not always followed these days because these best practices were basically initially proposed for a word processor, for example, but these days is more digital. More advanced tools are used for requirements management and writing requirements. But I will iterate them because also for the assignment and also for this project, software engineering project, you will need this. So always try to use wide margins for the paper that you are writing on your requirements. It will be easier to read. Use emphasis sparsely and consistently. So if there are any keywords, you should identify those keywords like I did here using the red. So you can use it as a bold or italic in your requirements document. So use always tables and bulleted numbers, so it gives a document more readable. So it's always easy to read tables than text. And also when you need to show a number of items of information with some table, try to use their commonalities and differences, so it will easier to compare those items even if they are requirements. And also when you are writing the equations, so if you're writing equations, try to make them separate from the text or the main body of the text and put it in a new line. And if you are describing a sequence of events, always use diagrams. So never use a list or sequence of bullets. So always try to use diagrams if it's a sequence of events, because for sure there will be a sequential relationship. And don't use complex diagrams because they are confusing. And try to minimize your diagrams in terms of elements, because large diagrams are usually not easy to read. So those were best practices for writing the requirements document, but there is also a guideline that your requirements document should be easy to change. So it's not only well written, it should be easy to change. So the first thing is your requirements document should be loose leaf binders. So instead of publishing as a book or instead of binding it, you should make it loose so that you can change or you can modify every single page. And also many word processors these days, even web-based word processors, they facilitate with change bars, so you can track your changes. It's also easy to it's also useful to use those track changes, because readers will get what change has been done. So always try to avoid reference to page numbers, because page number always changes or number of pages always changes. So it should not be used any page numbers in the text. All the figures and tables are labeled, and do not refer to any table like table below or table above. Always use the table numbers. Keep chapters short, and short chapters are always easy to read and understand. If you have a long chapter, people will be bored in the first place, and then they will get lost. So the benefit of the requirements document will not be reflected. Always start a new chapters on a separate page. So also I mentioned before, the requirements specification should be by chapter basis. So always start the new requirements in a new page or a new chapter, and this will make easy to change the requirements if you need to, for example, replace the whole chapter or the whole requirement. And always use page numbers relative to the chapter or science and the subsections. So if you have multiple pages in chapter 2, try to use 2.1, 2.2 in this way. So who are the users of the requirements document? So we have a well-defined requirement document. We have a well-defined requirement document structured requirement document. But who are the users? The first and foremost users of the requirement document is system customers. Then, of course, the managers. I also mentioned this too before. And the system engineers who develop the system. Then the fourth users are system maintenance engineer who use the requirement document to maintain the system. And also the system test engineers who test the requirements to see if it were properly developed or if it were developed according to the user requirements for the validation and test. So here I will show an example of a requirements or requirements document, let's say. And this is a example from the book of the second book I mentioned. So this is requirements from a insulin pump system. As you can see, they call it SRS in the first line. So they call it system requirements specification. So they don't call it requirements document. And the name of the requirements, as you can see, is 3.3.2. So it has some meaning. I will come to that meaning later. So what does this requirement do? So it compute insulin dose, that is the safe sugar level. So this is the main function. Then it has the description of the requirements. So it has more detailed description of the requirements. Then it has the input. So input is the current sugar reading, that is the R2, reading 2, and the two previous readings, so R0 and R2. So it relies on R0 and R2 and use the current reading to predict or to compute the comp dose, that is the output of this requirement. So comp dose is the number of dose in insulin to be delivered. So it has the action. So the action basically defines the logic, how this comp dose will be calculated. And finally, you have the precondition and postcondition. So the precondition is always like you should have sufficient dose in your stock, but the postcondition is most important. That is basically changing your variables. So as in the inputs, you saw that it relies on two previous readings, R0 and R2, and you have the current reading it relies on two previous readings, R0 and R1, but it also uses the current sugar reading, R2. So after this action, or after this requirements, or after this action is done, it will basically replace R0 by R1 and R1 by R2. So it will forget about R0, that was the input, and now it will consider R1 and R2 as the new input. So in this way, basically requirements are specified. So this is also an example of structure, how a specification of a requirement can be done in compared to previous two structures that I showed. So this was all about requirements document. So what's the time now? You want a break? You want a break for 5-10 minutes?
How much is it left?
We are still halfway, because it has a number of materials. So if you want, I can stop for a 10 minutes break and then continue.
I have some snack, but I think we need a break.
Yeah, okay. Then see you in 10 minutes. So welcome back. So I have around 50% slides left, so I will try to go a little bit faster. So we have looked at requirements and requirements engineering and also requirements document. Now it's more practical things, so requirements elicitation and analysis, and then how to describe the requirements. So requirements, so most of the things that I will mention here, I already mentioned before. So requirements elicitation is more about process of discovering the requirements. So you can do it by discussing with the stakeholders, by meeting them through emails, or even using some previous systems that you already have. And for this one, you also need application domain and organizational knowledge. So if you are developing a banking system, for example, you need to have financial knowledge and the banking rules, for example. So one of the key and most important thing for requirements elicitation is to identify and consult stakeholders. So if you don't correctly identify stakeholders, you will for sure miss some important requirements. And they have there is many benefits of correctly identifying and consulting stakeholders. So one of the key benefits that I mentioned is you will not miss important requirements. And then if you have diverse stakeholders, you will have diverse viewpoints, because different stakeholders have different roles and they have a different viewpoints of even for the same requirements. So you will get many viewpoints even from the same requirements from the same system. And if you involve different people in the organization for requirements elicitation, the good thing is that they will feel the part of the initiative or part of the product, and it will make them feel better. But how to identify the stakeholders? So primarily the stakeholders are the potential end users of the system. So they will know very well, or maybe the best, what they need as a requirements, and also try to read the description of the business process. So usually a organization of, let's say for a bank, they have a well-defined business process. So if they want to open a debit account for a customer, they know what are the steps. So they want to, if you want to develop a banking system, you need to read their business process for debit account, for example. And also the discussions with the management team, because the end users might have a very specific requirement, but the management might have very high level or very global requirements that are very important and may be missed by the end users. And of course the customers, because for the banking system we are the customers, so we might need to be, the customers might need to be consulted to identify requirements. And of course the developers who might have some development sorry.
They can't see the slides.
They cannot see the slides. Okay. I think now they can see. Yeah. So of course the development personnel, because they are developing the system and they might have some technical or technological constraint or requirement. And other regulatory bodies, like for financial systems, there might be a central bank or banking regulatories or authorities that you might to consider as a stakeholders. So you might, once you have the stakeholders and once you have the requirements, you also need to know in which environment those requirements will be running on. So the environment can be the hardware, that it can be the software systems that it will interact with, or it can be the host computer itself with a specific platform. So defining software operating environment is also important part of the requirements elicitation. And one of the main benefit of this, like if you already know the environment, you can handle easily any unexpected exceptions or interactions between the requirements or between the functionalities or between the requirements and the end users. And also defining the environment will help you to identify the compatibility requirements. So if you are upgrading a system, you might need to consider what's already in the previous system, and if you are putting new requirements or new functionalities, if there will be any compatibility issues or not, or if the requirement will match the current or existing requirements. So there are three potential environment or the types of environment that the requirement might deal with. So one of the platform information. So what are the operating system will be used for those system, for example, and what are the libraries that this product that I am delivering with or developing will be interacting with. And also the versions of the operating system and the versions of the libraries are most important, because these two are this version thing is one of the most critical problem or that can arise during the deployment or during the use or production. Then you also have the environment that is related to the interface. So if, for example, you are using a database system and you developed your program in Java, Java has a JDBC interface, for example, for connecting with the database, and you should have this JDBC version well defined and well set before or during the development. And also the software dependencies. So for example, if you are developing a banking system, you should have let's say generate the transactions or collect the transactions. So usually banking systems produce the transactions in a spreadsheet. So it's a external program, and you need to check if your requirements have any dependencies on those spreadsheets, for example, as a external environment or as a software dependencies. Then there is also requirements elicitation based on scenarios. So scenarios are basically stories, and these stories are basically interaction sessions between users. It's more about use case in UML. So you define your requirements as a story, how a facility or a feature will be used, and how it will be interacted with the user. But to develop the user scenario, you need to know the basic functionalities of the system. Then you can develop your story. So information that are crucial in scenarios. So when you are developing your story or scenarios, what information will be important for defining your or eliciting your requirements. So the first one is the state of the system. So what will be the state of the system before entering the scenario or before starting the story? The flow of the events in the scenario, the exceptions of the normal flow. So what can go wrong during the stories. So information about other activities, like if there is any parallel sessions or parallel story going on, and also the description of the system. So that is the post state of the system after the story. So what has been concluded with the story or with the scenario. So what we have achieved basically. So usually the stories should be 3 to 4 pages maximum, and it can include tables, flowcharts, and other stuff. So it should not be that long if you are describing your requirements using stories or scenarios. So now come back to the requirements elicitation and analysis. So as I mentioned before, requirements engineering process is a set of structured and sequenced sequence of activities. So it gives a good example of this structure and the activities. So let me give you the short overview. So we start here with the domain understanding. let's say we again come back to the financial example or banking example. So we have to have a banking understanding of or the understanding of banking domain. So we goes to the requirements collection. So we collect the requirements from the user. From once we have the requirements, we do their classification. So we make relations between the requirements or among the requirements. If there are any conflict or any problems with the requirements, we go for the conflict resolution. And if there is no conflict, we go for the prioritization. So we might have 10 requirements and we might prioritize 8 of them. So we select those 8 requirements. And we finally check them for, so it's basically requirements validation. So we check if they are complete, if they are concrete, if they are consistent, and if they are correctly written. And once everything is done as a requirements validation, we go for the requirements specification. So this specification includes the system requirements and also the user requirements. And from there, you can basically come to the requirements document, where it includes the models, the diagrams, the input and output of each requirements, and what they are doing. But important thing about this figure is that, as you can see, there is no going back from requirement document to requirement specification, but they have always going back from each step to the previous step. So if you have, so if you first have domain understanding and you do the requirements collection, and while you are doing the requirements collection, you find some problems, so you go back. So in the same way, if you find any conflict in this step, you go back to classification. If you find any problems in the requirements checking step, like if there is any consistency issue or a conflicting issue or writing issue, you go back to previous step. So you go back basically all the way to first step. But once you have your document, you cannot go back, because once you have your document, if you have any problems, you need to redo the whole thing. So you will have a new version of the requirements document. So there is no way to go back that you change your specification and you modify your requirements document. But if you have requirements specification problem, you can basically go back all the way to domain understanding problem. So that means you have lack of knowledge and skills to specify your requirements. Then for the requirements analysis, so once you have the requirements that are elicited from the stakeholders, you need to do the analysis. So in this figure is part of classification, conflict resolution, prioritization. And in these steps, you analyze each requirement and you come to a conclusion with an agreed set of requirements that will be implemented. And this is done through negotiation. And when we are dealing with this negotiation, so because I mentioned that analysis involves classification, conflict resolution, and prioritization, they are dealing with high-level statements of requirements, so they don't have any models or diagrams yet. But once you do your requirements analysis and negotiation, you may find as an output some criteria or some decisions. So some requirements might be missing, some requirements might be unrealistic, some could be conflicting, or some could be overlapping or ambiguous. So what you do for missing requirements, you simply add the requirements to your requirement set. For unrealistic and conflicting requirements, you remove them, because first of all, those are unrealistic and they are conflicting each other. And for the overlapping and ambiguous requirements, you modify them and you keep them in your requirements pool. So these are the actions for different types of requirements problems. So there is another critical figure, I would say critical and important also, for requirements elicitation and negotiation. And again, I present it in a spiral. So as you can see, it has 3 different activities: requirements elicitation, requirements analysis, and requirements negotiation. So you elicit requirements here from the stakeholders, you analyze them, and you negotiate with the stakeholders if you find any problems. But there is also 3 dimensions. One is for the requirements problems, then you have the statements of the requirements, and you have requirements document. So the more away from the center, for the requirements document and the requirements statement, it gets more matured. But more away from the center, from requirements problem, means you have more issues or problems in your requirements. So it's the other way. But it has 3 critical points, as I marked here. These points are critical because this is the first point when you elicit the requirements and you have draft statements. So the requirements are really not well written. This is the first point where you have many problems with the requirements, and the more you go up, the less problems you will have. And then this is the first point, you have the first version of the requirements document, so it will have also many problems in the requirement document. But over the time they will improve, and at some point you reach a more stable point. So these green points, that are more stable requirement document, more stable requirement statement, and very few problems in the requirements. So our goal is to achieve basically these green points at some point. So there should be a checklist for requirement analysis. So we are in the requirements analysis and negotiation phase, and if we can develop a checklist, then we can maybe more formally analyze requirements. And this checklist is basically a list of questions that if you can answer properly, will tell you if you have problems in your requirements or not. So for example, the premature design. So does your requirement include premature design or implementation information? So you should not have any premature design or information implementation because you are very early stages of requirements analysis. If it has any premature information, that means you have a problem in your requirements analysis. And the second thing is the combined requirements. So you might have requirements that can be broken down further sub-requirements or maybe other main requirements. So if you have this issue, that means again you have a problem in the requirements statement. Then if this requirement is gold plating, so some requirements you don't necessarily need. So if it's a gold plating requirements, that means you can remove these unnecessary requirements. Then also the non-standard hardware. If some requirements are using non-standard hardware, that means your requirements is not up to date or it's not using widely used platforms. Conformance with the business logic. So if the requirements is consistent with the business logics. So if it's not consistent with the business logics, that means it does not it should not be included in your requirement set, and it's conflicted with your high-level business goals. And also, if the requirements is ambiguous, so if it's ambiguous, that means you also have a problem with the requirements statement. And then the realistic issue and the testable issue. So the requirements had to be realistic, given the technology we have to implement and basically the platform that we want to deploy. And also the requirements must be testable. So if it's not a testable requirements, that means either you have a problem with the requirements or you have to remove it from your requirement set. Because without testing a requirement, you never are able to deliver a requirement to the customer. So never have more than 10 questions in your checklist for requirement analysis, else it will be too long and the requirements engineers will not follow it. So we always have conflicts or overlaps or omissions in requirements. So how we can conflict or resolve those conflicts? So the best way is to have a requirements negotiation meetings, where we basically discuss requirements with the stakeholders and take actions. So either we want to keep the requirements or remove the requirements. So what is the benefit of conflicting resolution conflicting? The first benefit is that if you have a meeting with your stakeholders, so negotiation meetings, it will reduce your time to arrive on an agreed set of requirements. And also, if you make it an open process, it will make sure that you do not miss any critical requirements. So if you do not meet your stakeholders in a formal meeting, and you decide yourself to remove critical requirements, it might be very bad for the other stakeholders. So usually the negotiation meetings have 3 stages, and they are done in 3 stages or in three phases. So one is the information stage, where you basically in a meeting present each requirement and the problems with related to that requirement. Then the discussion stage. So after the presentation, you discuss with the stakeholders how this problem can be resolved. And then the resolution stage. So what actions should be taken, and in this resolution stage, you have to make sure that you agree with your stakeholders by not forcing your own decision on a requirement. So one of the key point or key phase for requirement analysis is to prioritize requirements. And the goal of prioritizing requirements is to give more or less importance to some requirements, but that can be developed or delivered either giving priorities, or maybe developed or delivered later based on the priorities. And of course, priorities should be assigned again by discussing with the stakeholders. So you cannot assign priorities by whatever you want. And the benefits of those assigning priorities to requirements is that if you get a high priority sets of requirement, that means those are the core requirements of the system. So you deliver or you develop them first, and then you focus on the rest, basically. So ideally, in a real scenario, the priorities should be assigned during the elicitation process, but basically it's too early to know the importance of those requirements. So unless you have a prototype, or unless you have a meeting with your stakeholders, if you take the requirements from the stakeholders and simply assign priorities, that will not work at the end. And priorities should be done on a small number of scale. So there could be maybe 3 classes of priorities to make it simple. So it can be essential, it can be useful, or desirable. So essential is essential requirements are those that you must or you have to include in the system. And then the useful requirements could be that you could have, and it will be good if you could have them, but it will not be a big problem if you don't have them. And the desirable is like you can optionally avoid them in the first delivery phase, for example, but it could be delivered as a like improving the visibility or user interface, this kind of requirements. And after you so one of the part of requirements analysis is classifying the requirements. So there is many ways of classifying the requirements. I will discuss one of them, but always it's good to classify your requirements using a multi-dimensional classification, because requirements could be related to each other. So one requirements could be in many classifications, and is also true for vice versa. So many requirements can fall under one classification or single classification. And if we do the classification of requirements, it will basically show what are the common or similar requirements, and what will be the relationships between the requirements. And if we have multiple classification in our schema, and if we find that one schema is completely empty, I will show an example, then it hints that there might be missing requirements. And one of the most common approach for requirements classification is faceted approach. So basically, in faceted approach, you predefine a set of classification groups, and you take each of your requirements and justify yourself, or based on your experience or judgment, which group it will go. For example, you might have system requirements, you might have user interface requirement, you might have database requirement, you might have communication. So you have this 4 group, and you have sets of 10 requirements. So you take each one requirement of those 10 and put them in one of this group. So after deciding that's what I said, but here is the example. A requirement saying a graphical user interface to the account data should be provided. So what will be the possible classification? So this question is for you. So we want a user interface, and we want to show the user account data. So it can be a banking data, or it can be any data. So what classifications this requirement can fall under? Yeah, and then it can be also database requirements, because you are managing user data. And it can be also security requirements, because user data should be handled or managed in a secured way. So each requirements might also have risk. So risk in terms of implementation, and risk in terms of if they have risk on the system itself. And there is many other ways to assess this risk. I will show one approach here, but the benefits of assessing a requirements risk is that it will identify the system or the requirements that are more volatile, or that can delay the delivery process, that can impact the overall system's performance. So if we can assess the requirements risk beforehand, the development, we can take extra care for them. But also assigning risk, or if there are any risk with the requirements, by reading it, it might be because of there is insufficient information in the requirements. So the developers might develop a wrong requirements by reading it. So we might need to improve the requirements itself. So one of the way of assessing risk is to answer this or to follow this structure. So there can be many risks imposed by the requirements implementation. So we have to ask ourselves, so if we implement this requirement, does it have any performance risk? If it has a performance risk, we can mark it down. Then it might have also safety and security risk. It might have process risks. So our regular process might not be enough to implement to this requirement. For example, we might need unfamiliar prototype systems, or maybe a mathematical notations for safety requirements. Then we might also have implementation risk. So that is more about technology. So for certain requirements, we might need advanced techniques like artificial intelligence, or we might need inversion programming techniques for fault tolerance. So we have multiple versions of the system, and if one version of the system fails, the other version takes on. So there is many issues that we need to consider for a requirement. There is database risk. So if the requirements is handling database, we need to make sure that it does not involve in non-standard data. Then also schedule risk. So we have to make sure that the requirements we're implementing will not fail the schedule or the deadline. And then there is also external risk and stability risk. So the requirements should not be volatile, and it should not be changed that often during the development process or during its lifetime. So we need to mark each of the requirements with these risk levels. And also do not use numeric risk levels, because some the risks are imprecise. So try to use these fuzzy categories like high, medium, and low, and it will be easier for the developers or the requirements stakeholders to get the risk just by looking at them. And finally, the requirements description. So there is no good way also for describing the requirements, and usually the requirements that are written in a text format or natural languages, they are ambiguous and not clear and often misunderstood. So we need to be very careful about writing the requirements in a good way. So there are a number of problems that are found for the requirements that are written using natural language or in a text. One of the common problem is writing complex conditional clauses, like if requirements A happens, then the requirements B, and then do requirements C. So this kind of complex conditional clauses in the text breaks the readability. Then also the use of terminology. So you should not use sloppy or inconsistent terms for the requirements. And also, as a writer, do not assume that the readers will have always same or specific knowledge as you when you are writing the requirements. So readers should understand the requirements by whatever you wrote. So there are three essential ways, I would say two, to improve requirements description. So the first and foremost is always invest more time in writing requirements, and review it and improve it with more effort. So there is no alternative of effort and time for writing good requirements. And also, as a writer, as a requirement analyst, do not assume that you always have, or the readers always have, same background and knowledge. So try to read or try to write requirements as if nobody knows nothing. So there are many ways of writing requirements or writing requirements specifications. So one of the common that is most ambiguous is natural language sentences, where you write your requirements in your own word. Then there is also structured natural languages. So apart from the natural language sentences, you basically use a table or template or form, but again you are writing in a natural language. Then there is design description languages. So you can going away little bit, becoming more formal. You can use different diagrams or models or programming languages to represent your requirements. So this is not UML. UML is basically the next phase, graphical notations. But there is other semi-automatic or semi-formal graphic design languages like Visual Basic or Visual Fox Pro or other languages that you can design your database, or you can design your requirements. And then the graphical notations, as I mentioned, the UML, the most commonly used graphical modeling language. So you also mark your models and annotate your models using text, because you need to understand the models as a reader. And the most formal ways to write your requirements in mathematical specifications. That is not very easy to understand for the general readers, but some mission critical softwares, they use mathematical specifications, especially for safety reasons, safety systems. So if I want to compare these sets of requirements writing specifications, so from the natural language until mathematical specifications, you go from least formal to most formal, and from mathematical specifications to natural language sentences, you go from least ambiguous to most ambiguous. So both of has their own advantages and disadvantages. So there are some general guidelines for describing requirements. So one of the useful guideline is to use a standard templates for describing requirements. It will make your requirements easy to write, read, and modify. So this is also done in today's software development projects, where they follow a template for writing requirements. They also use databases. Then also use your language simply, consistently, and concisely. So if your language is not very easy to read and not very easy to follow, that means your requirements has problems in terms of from the view of readers and also from the view of writers. So developers will read your requirements and develop a wrong product, for example, if they don't understand your requirements. And testers will test it in another way. So there will be a complete mess with the developers and testers and end users. So use the diagram appropriately. So whenever possible, always use diagrams, because diagrams are more effective and powerful for writing or for expressing the requirements. And then also try to supplement natural language with other descriptions of requirements. So not always natural language. Natural language is easy to express or write, but if you want to use natural language, try to use, for example, timing diagram or data flow diagrams. So basically, it's good to combine natural language and UML models, for example. So I want to conclude the lecture, but before concluding the lecture, I want to basically highlight whatever we have discussed and whatever we have learned today. So the first thing is the requirements. So the requirements are basically nothing but the descriptions of how the system should behave, or how the system, what are the system property we should have or we expect from the end users and from the stakeholders. Then the requirements engineering. So requirements engineering is engineering of the requirements that covers all activities, including discovering, documenting, and maintaining requirements for a computer-based systems, but it does not concern, or it does not deal with the structure or the sequence of those activities, but requirements engineering process does. Then there is also requirements document. So it's an official document of the requirements for customers, end users, and other stakeholders like software developers. And then there is broadly two categories of requirements. So one is based on the level of details, that is user requirements and system requirements. And also there is based on the goals. Requirements can be functional and non-functional requirements. So functional requirements are all about actions and features, and non-functional requirements are all about how those actions and features can be performed. Then there is also requirements engineering process. So in contrast to requirements engineering process is a structured set of activities that also does similar thing, but in a structured way or in a formal way, in a well-defined way. Then there is also target audience. So who are the target audience of the requirements document that we defined? So the target audience are the system customers, managers, system engineers. So basically all the people who took part in the requirements elicitation are the target audience of the requirements. Then there is requirements elicitation. So what we mean by requirements elicitation? So this is the process of discovering the requirements. So it does not include the requirements analysis or even requirements negotiation. It simply deals with the requirements gathering. And then there is also a system stakeholder. So system stakeholder is anyone who benefit directly or indirectly from it. So system stakeholder are most of the time same as target audience of the requirements document, but requirements document not necessarily, the audience of requirement document are not necessarily always the system stakeholder. And lastly, the objective of requirements analysis and negotiation. So the main objective of this step or of this activity is to establish a agreed set of requirements. So we need to discuss requirements, we need to negotiate our demands, and we need to come up with a agreed set of common requirements that will be implemented and tested and delivered. And the goal of this phase is not to have ambiguous requirement, and so that the requirements are written consistently and precisely. So if you have any questions, I can answer some of them. I think I have some time, or we can go for the next lecture. So no questions so far in the Slack? No, okay. So if you don't have any question, then see you on Friday, right? And on Friday we will discuss on requirements validation and management, and that will be also kind of long, but it will give you some more ideas about how to manage requirements and how to validate requirements using some well-defined process or steps. Thank you then.